Alright. I think, yeah, everything looks good. Okay, so I'm gonna be working on more physics joints today. Actually, I haven't decided which joint I'm gonna be working on, because I'm actually done, well, mostly done with the hinge joint, which I can actually show something interesting with now. I did earlier today discover a pretty big bug with the hinge joint, because I was calculating the well, I was using the incorrect transform essentially. I was using the, let's turn off bloom. I was using the local transform, whereas I should have been using the world space transform. Now, there are two chains here, courtesy of Tim, who actually sent me these extremely good looking chains. No, I actually like the way they look. They're just a bunch of elongated toruses. And effectively, these two kind of top chain links are static actors, so they don't move. And every single link in the chain, except for the last one, is a hinge joint that will be rotating around the local x-axis. So if I hit simulate here, we get some pretty nice chain physics, which typically you wouldn't actually use hinge joints for that. You'd use something like spherical joints or a distance joint, but hinge joint works just fine. And I think it's quite cool. But yeah, so pretty much done with hinge joints. So I'm considering either implementing a spherical joint, which is basically like a ball inside a socket. So it's kind of, the rotation is constrained to within a given kind of cone angle. Or I may do a D6 joint, which is literally the most complex joint that physics provides, which, yeah, it's a challenge to implement that. The thing is, I was looking at how Unity, like what kind of joint Unity's character joint is, because that's the one they use for ragdolls, and it's an extended ball socket joint, which so they basically taken the spherical joint and made some modifications to it, which I'm definitely not skilled enough to do. So I'm probably gonna go for a D6 joint and kind of start off only implementing the stuff that we need for ragdolls. And I'm actually gonna bring up the ragdoll to-do list. Seems like someone else has made an issue as well, so updating prefab names. Okay, interesting. And here I even say like D6 joint. But I specifically want to take a look at this physics ragdoll repository, which is what I'm going to be using as a reference. So if we come down here, we will see this example uses a hinge joint, and other than that it just uses D6 joints, which I'm not sure like how. Yeah, and they use a very, very simple D6 joint, I think. Yeah. Which I think is good, because we're gonna be effectively copying this to a degree. Also, yeah, I'm pretty tired because I didn't sleep, and I didn't sleep tonight, but I managed to get, 4 hours of sleep now during the day. So, the one thing that's kind of annoying is that right now I don't have a way of visualizing joints in a good way in Hazel. Like if we take a look at this is a this is a hinge joint. We can see there's a little yellow sphere, purple sphere, sorry. And that literally just represents the anchor offset. But the thing is, there are so many more parameters that I can visualize, like the axis that it's going to rotate around, the rotation limits, that kind of stuff. And I do want to actually have proper visualization of those parameters at some point. But I think for now I'm going to start working on the D6 joint, which I think Unity actually calls a configurable joint. Yeah. And I mean, you can see how many parameters there are. There's a lot of them. So, let's get into the code. And I'm going to be using this. I'm going to be keeping this on my second monitor probably. So, and I'm probably gonna call it configurable joint component as well for now. Purely because I can't bother coming up with a better name. Actually, I'm gonna keep it here. Okay, so as with all joints, we need to know which entity we're going to be connected to, if it's a breakable joint, and how much it will take to break it, whether we'll have collision or pre-processing enabled. Mass scale is probably going to be a thing. Not sure if offset is going to be... Yeah, actually it's going to be a thing. I'm pretty sure, at least. Yeah, I'm gonna have to not deal with that for now. Okay, let's take a look. We have swinging parameters. So I'm probably going to have, what is that? D6 like motion type enum. Let's actually include D6 join. Why is there two files for it? Okay. Okay, so we're going to have locked limited free for the actual motion type. What's up, Tony? So I'm just gonna go ahead and bring this one over to the side. Configurable motion type. Locked. Free. It's locked and does not allow relative motion. Limited, it only allows motion within a specific range, and it's free in its full range of motion. Nothing's broken. In fact, everything is working perfectly. Let me show you. Because I managed to get hinge joints working perfectly. For the most part. There's probably still some quirkiness with it sometimes, but it seems to be working. And then I did something wrong with that. Yeah, probably. Like, I'm sure there's still some bug somewhere in that code that's gonna come back to bite me in the ass. But for now, it works. And I regret making these changes because now I have to recompile the entire damn engine. No microphone picking up that. No, I don't think so. Come on, give me some faster compile times. Do I not have multiprocessor compilation on? I don't know. Slovitz. Why are all the components in the same header? Organization purposes. Most of the components are absolutely tiny, and we have a general philosophy that people just shouldn't care about having massive files. To us, it's easier to navigate this than trying to find, 50 different files in the entire structure. Especially because if you have, say, Visual Assistant installed, you can just do Alt-M and just type in whatever component you're looking for. So let's say I want the audio listener. Done. So yeah. Okay, so we have chains. Hit simulate. They behave like chains, using hinge joints. So, cool. You see, tell me, works. And then the 550k lines. Yeah, but like, that's fine. Like, we don't mind that. Because, like, in my mind, it's harder to navigate, like, 100 different files. Like, I don't know how many components we actually have here. If you search for, I can't search the shot. But like, first of all, this isn't a lot of code. This is 469 lines of code. Yeah, but like compile times, we have multiprocessor compilation on. And yeah, obviously the compile times do increase. Like, that's a given with any kind of header files. But it's not a big deal to us. We can work with it. Also, I feel like we have more components than this, but apparently not. Either way, D6 joints, right? Okay, this is interesting. We have X, Y, Z, twist, swing, swing. So along and around. That's interesting. That means I could still use this one, because this is the axis that we can use to specify the hinge joint axis. But seeing as these three last parameters are only ever used by the D6 joint, I can simply add those to the end and then only display X, Y, and Z for the hinge joint. Yeah, let's do that. Twist 1, swing 2. Should probably make notes of what they actually represent. Along the axis. Except that's not technically true for hinge joints. For hinge joints, this is around the axis. But am I gonna go ahead and separate the hinge joint rotation axis and the D6 joint rotation axis? Because these do kind of represent different things depending on the joint. Nah, it's fine. I'll just say for D6 joints X, Y, and Z represent rotation along the axis, twist and swing is around the axis. And just for hinge joints X, Y, and Z represent rotation around the axis. Twist and swing unused. Now we can configure this. Wait. Should that be an enum? Because this is... I think I'll get some more components that I'm still missing on my PCB. Should probably do that. So here we actually configure multiple of these axes. So we wouldn't just have... Oh, but in that case, I'm not gonna add these in here, because they're not gonna be used like an enum. Instead, we're gonna have like swing one axis, which is around the X, no, around the Y axis. Last time when I got more of them, I was like, why do these look so small? Then I compared and they were like half the size of my others. Awesome. That's why I measure before ordering. Swing 2 is Z, and twist axis, which is X. And we need the stop selecting menu items, twist motion type, which will set to limited by default. And yes, once I had the bigger ones were already... That's tiny. And the ones you got were even smaller. Dang. Swing 1, motion type, and swing 2, motion type. Any other parameters? Yes. Swing limits for these two. So there floats, yeah. Well, for the twist we have a low and high rotation limit. So similar to what we had here. Lower twist, lower rotation limit. Upper rotation limit. And these are what exactly? That is the same thing that we have here. Except, I guess maybe it's for code. Let's just say Oh, so I guess these could be described as the angular axes, whereas these are the linear. Yeah, that makes sense. Yeah, the ones I have to add are 1.6 millimeters by 0.8 by 0.5. Jesus, that's small. I'm probably just gonna do this for now. Because I don't know what these apply to or what they represent yet. And that seems to be everything that this guy has used. Which I guess is nice. This component will grow to be a lot bigger. So let's make sure we're copying it everywhere. And the whole component copying thing, we're probably gonna overhaul that to be a lot more like Hazel 2D, where you basically just have a list of all components instead of having to go through and actually manually do all of this. Then we have the joints. Because going through and manually adding these is painful. Okay. Prefab. And I think that's everywhere. I should get going if I wanted today. You do that. I'll see you later, Tony. Yep, that's everywhere. Good. Now for the actual UI. Just gonna copy the hinge joint. One and a half hours. We'll see if I'll be still be live then. It's probably gonna be a pretty short stream either way. Figure though. But yeah, either way. Connect identity, yep. Anchor offset. This is gonna change. Is breakable break force, rotation limits. We're gonna want something like that, but not exactly like this. Same thing with the motor. Mass scale, yep, that's whatever we will want. Connected mass scale, same thing there, I assume. Okay. Let's close some of these files. Bring components over to the right side. Man, I have a lot of files open. So let's actually end the grid. Begin the grid. Because we're gonna have a property grid header. I was gonna be gonna present this. They actually just present that. Yeah. So they don't actually have this, which I guess makes sense. Let's steal this. Configure motion type. And if you're wondering what all of this code is for, it's for multi-component editing. So that we can display like mixed value symbols and things like that. And it currently doesn't look that good with twist motion type, which this is going to be a drop down. Also, what's this music? Also, I'm hoping that my stream doesn't randomly crash like it did yesterday, because that would be seriously annoying. Drop down. It's called and I'm gonna be referring a lot to Unity's kind of names for these because they tend to have pretty good naming conventions. So angular x-axis motion. And the parameters for this is what exactly? I know there's one that takes an enum. The underlying type being like an int in this case, I think. Which I don't technically have to specify. Okay. So I wish there was a way to get the names from the actual enum class, but that would require like reflection and stuff like that, which isn't really something that C++ likes. Well, I think there's talk of like reflections, like runtime reflection being a thing, or at the very least runtime type information being a thing in C++ 23, I think it was. The option count, which is 3, and the selected being the twist motion type. You complaining? Or no, wasn't real error. Let's do that. Get a bit more space here. I won't be bothering with tooltips for now. Y, which is wing 1 motion type. Should probably name these like angular Y motion or something. Instead of bothering with these technical names. Z-axis motion. Swing 2. Yeah, I'm gonna rename them. I'm sorry. Why won't you? Okay, fine. So this is the y-axis. Yep. So angular motion Y. Let's call it. And I'm gonna redo that because it probably didn't rename everything properly. Oh, come on. No, actually it did, shockingly enough. Except up here. Because we weren't using this up here. Let's just quickly add up there. And this becomes angular motion X. That one definitely didn't rename properly. Super annoying when it does that. Why can't it detect that this is a thing? And... What? In video release. Hello? Angular motion Z. And yes, please rename that as well. Thank you. I just want to get this sort of done before I start serializing things, because that's just gonna make it really annoying to debug. Then we have rotation limits and... Okay, so this is the angular motion X limit, lower and upper, but I guess for Y and Z we provide this instead. We don't have 2 per axis for those, which I think makes sense considering the fact that it says where did it say that? It said somewhere. Twist around that and swing around the Y and Z axes. So I guess maybe these combine in some way. So let's actually rename. Didn't want to find the references. Okay. A rotation limit. Angular limit. Fine. Angular limit. X. Limit X. And I guess this is just the Y angular limit. And Y and Z. or something. Sherry Coder, thank you so much for following. Much appreciated. Man, I just realized I'm really close to 300 followers. 279 right now. Cool. I see you. What is this code? I'm not editing Danish journey component. Good. We've got to update it in a bunch of places. Somehow. Okay, good. So this is going to be angular lower limit x. It's a float. This is not important. Tooltip doesn't matter right now. Upper limit x, which we could make these kind of inline with each other, but I can't be bothered because I actually want to get to implementing it. But I kind of have to do UI first, but I can play around with the different values. And this is the angular limit on the y-axis. Teach Celia, what's up, man? How's things? Been a while since I've seen you here. Yep, that's correct. Angular limit z. Okay, I think that's all of those. Let's go ahead and close this. I need to find the draw add component buttons. Should probably add categories to these. Configurable join component. Configurable. Which isn't the most descriptive name, but whatever. Just working on an engine to learn stuff. Cool. That's awesome. Might as well learn C#.NET Dev as it's easier to find jobs. Yeah, there's a lot of .NET, well, specifically C# jobs available right now, it seems like. I feel like the entry point for most kind of workplaces when it comes to game engines is quite high, which is also really annoying. Why didn't my music stop? There we go. So yeah, that's probably a good idea. yeah, they're like, I think like I applied for a junior engineer position at EA a while back, and I think they required like 2 years professional experience. Oh, damn, didn't realize that. But yeah, like, no, they require like 2 years of professional experience for a junior level position, which is not the definition of a junior level position. So I have no idea what the best kind of geometry for testing these configurable joints will be. I imagine we can test them with the chains later on. For now, I'll go with cubes. Let's have configurable joint and just for organization. Cube. Scale that down a bit. Bring that one down and bring the entire. Let's reset the X and Z positions so they're like that. Okay, save that. So if I add configurable joint here, we get a bunch of options, and I have no idea what any of them mean. Well, I have a rough idea. Like, I know what anchor offset is, I know approximately what these represent, but I don't know visually what they look like. The limits are, like, I have no idea. Because for a hinge joint we have the lower and upper limit, but that's it. There's no other limits involved. So yeah, let's start writing the API. Well, I should add serialization before that, purely because otherwise I'm gonna have to recreate that joint every time, which is gonna be painful. So we have connected entity, we have anchor offset, we don't have that. We do have these, but they're gonna be lowered down. We don't have any of these at all. Cool. So let's start by writing out these. Angular motion X, which will be cost down to an infinite t. Angular lower limit X. Is the import STD from C++ implemented yet? Yeah, like that's modules, right? Although, like, I don't know what the state of modules is right now in C++. I know that the compiler support for it used to be, like a year ago, it was complete garbage. Basically, only MSVC supported modules properly. Don't know if that's still the case though. But modules are actually quite a cool thing that can help speed up compile times, among other things, and help with organization. Probably serialize these together. Yeah, I think they're a very interesting thing that was added. Okay. Rename. I'll just do for this selection RJC to CJC. Just for consistency, some were made and some weren't. Of course. Because it's that slow. No. Selection. There we go. It would be cool to have a standardized package manager for C++ to make it easier for libs. I mean, absolutely, it would be nice. But like, I've also found that package managers are very nice, but they're not, like, for me, they're not a requirement. They're not something that, like, prevents me from writing and using a library or whatever. But they're definitely nice to have. And I do think we should have, like, an option for it. Although, I mean, good luck finding someone willing to write a standardized package manager for C++. I don't think that's very likely to happen, to be honest. Which is kind of unfortunate. And little limit. Should provide default values. Command id 0. And then we just have the other limits. Limit y, z, okay, that should be serialization done. So now we should finally be able to start working on the actual joint API. Give me a second, gotta go get more coffee. All right, there we go. Still not done compiling. Also, does the stream keep buffering for you guys? Because I'm watching on the Twitch dashboard and it keeps buffering for some reason, even though I have it on like 480p, just so I can like preview. Okay, let's again add configurable joint. Let's maybe set Y to locked and Z to free. Set this to something, that to another thing, that hit save. Restart it. Just to make sure that the serialization works. Limited lock free. Yep, that looks good to me. Let's reset the components. Save that. Cool. So now we actually get to the fun part, where we have to. I'm gonna have to I'm probably gonna rework this API when it's time to integrate this with Jolt, which I'm actually really excited to work on, maybe during the weekend. D6 joint create D6 joint. Okay, let's quickly steal this code and completely rewrite it. So if it doesn't have a configurable joint component, yes, that's a component, exactly, or not. And I hope that the local frame calculations are mostly the same for D6 joints as it is for hinge joints. Configurable. Need to update this to have a configurable. Configurable. Right, so rotation axis, not actually a thing. I'll get back to that. Maybe we don't have to set that at all. This is where this becomes an issue, because when we calculate this, we do this. We may have to do this differently for configurable joints. For now, what I'm gonna do is just hard code this to be X. I'll probably do the same thing up here for now. But this is good. This means that I'm gonna have to rework the API just a little bit. Maybe I can't generalize the local frame calculation. Maybe I can, I don't know. D6 joint. Should be the same parameters, I think. Yep. I believe the local frames represent the same thing, yeah. It's breakable, yada yada. This is not a thing. Inverse mass scale is a thing. That's not a thing. This could be a thing, but it's not gonna be. Same thing there, at least not for now. Collision enable, yes. Referencing, yes. Visualization, yep. Alright, so let's take a look at the configuration here. Set motion. Okay, so that's where we do that. Kind of wondering where we should do that. Let's do it up here. Set motion. Hang on. What's the actual type? Axis. Sorry. D6 axis. twist. I don't think I can just do a direct cast here. Does this contain... Actually, yeah, no, I can. I can just do a direct cast to physics, dx6, motion, enum, maybe I have to specify? X. Don't know if that's correct. Swing 1 and swing 2. Y, Z. Let's quickly try and compile that, see if that works. That compiles good. Swing and twist limit. Okay, so what are these parameters? The Y limit angle, the Z limit angle, and the contact distance. Okay, so I was correct in that. And contact distance I don't really care about right now. Twist limit, which takes joint angular limit pair. So that's for the X axis. Okay. Now they do have some default values here, which is interesting. But let's just check if this actually, like, if this works and how it looks. Where do we create joints? Here. Let's give it a go. See if it works. I should have probably run this in debug mode so I can open up the physics debugger as well. See the bloom. Okay. Let's give it this cube and say that you are a rigid body that is dynamic. Okay. That looks pretty normal. At least nothing broke. Let's try this test. Let's see what happens. It broke. let's make it not be breakable. Okay. That's interesting. Let's say free. Suspect it's because of this. Let's quickly go ahead and give them some default values like they did in here. So it's YC lower upper. Let's just quickly steal these into here. So Y Z, and then it was upper lower, lower upper, lower upper. And upper.